15 years of storm event records, 1.2 million rows, every tornado, flood, blizzard, and hail event logged by the National Weather Service forecasters across every county in the United States. The data is public, free, and sitting on a government server waiting to be downloaded. It is also stored across dozens of CSV files with inconsistent column names, 3 different date formats, property damage values that mix text and numbers, and narrative fields that range from 2 sentences to 12 paragraphs written by 100 different forecasters over 15 years. This is not a broken data set. This is what real operational data looks like. The pipeline you build in this article turns into something a language model can actually use. This is Getting Data In, Models Part 6. Clean data doesn't walk itself into the pipeline. Here's how you construct the funnel. This article has a mix of explanation and Cloud Code prompting. Rather than provide a voiceover for these type of hybrid articles, I will provide a summary of the sections and prompting. The full text on how to build your data pipeline to prepare for ingesting into the model framework can be found on Substack. Section 1. Why the pipeline order matters. The sequence matters. Normalization has to happen before cleaning because you cannot identify duplicate records until inconsistent representations of the same entity have been resolved into a canonical form. Cleaning has to happen before formatting because you don't want to build well-structured documents out of corrupt or incomplete records. Formatting has to happen before chunking because chunking decisions depend on the structure of the document, not on the structure of the raw CSV row. Section 2. Getting the data. NOAA publishes storm event data through the National Centers for Environmental Information. The dataset is available as annual CSV files going back to 1950. For this ARC, we work with a 5-year window, 2019 to 2023. This produces a manageable corpus with enough volume to make every pipeline decision meaningful. Each annual file contains 3 related tables: event details, fatalities, and locations. The event details is the primary source. It contains the structured fields and the narrative text that together make each record useful for language model retrieval. Step 1. Getting the data starts with downloading CSV files. The article includes a prompt for Cloud Code to create a download script that pulls the NOAA storm event files directly from the government server, verifies every file arrived intact, and sets up the directory structure the rest of the pipeline depends on. You pick the date range, the script handles the rest. Step 2. Data normalization to resolve the 3 structural problems in the raw files. Here again is a Cloud Code prompt for a Python script to manage these structural problems. County name variants become a single canonical form. Historical event type classifications map to their current equivalents. Property damage values stored as 2.3M become 2300000. Every record in the dataset speaks the same language before anything else touches it. Step 3 starts with another Cloud Code prompt to create a script to clean what normalization cannot fix. Missing narratives get flagged, duplicates get resolved, short records get identified. You get a report before the next step runs so you know exactly what you're working with. Step 4 creates a formatting script that converts each cleaned row into a document. Structured metadata and narrative text are combined into a single coherent unit. Every original field is preserved as metadata for filtering at retrieval time. Step 5. A chunking script that prepares those documents for the embedding model. Single events become single chunks. Long episode narratives get a sliding window with overlap, so context does not break at the boundaries. 5 steps, 5 Cloud Code prompts, 1 directory of pipeline-ready documents at the end. This article has everything you need to run it.